Let's know about our Mother Earth. The Earth may look solid, but inside it is made of four main layers. The outermost layer is the crust, thin like the skin of an apple. It's where we live, and it is broken into tectonic plates that float and move, causing earthquakes and volcanoes. Beneath the crust is the mantle, the thickest layer made of hot, semi-solid rock. The slow movement of the mantle drives plate motion and shapes mountains and volcanoes. Next is the outer core, a layer of liquid iron and nickel. Its constant movement generates the Earth's magnetic field, which protects us from harmful solar radiation. At the center lies the inner core, a solid ball of iron and nickel. Even though it's as hot as the sun, the massive pressure keeps it solid. So, crust, mantle, outer core, and inner core, four layers that make our planet dynamic, alive, and always changing. As we move ahead, let's ponder on the disastrous earthquake. An earthquake is one of the most powerful and frightening natural events on our planet. In just a few seconds, the ground can shake so violently that buildings collapse, bridges crack, and landscapes change forever. But what really causes an earthquake? To understand this, we need to look deep beneath our feet at something called tectonic plates. The Earth's outer shell, which we call the lithosphere, is not a single solid surface. Instead, it is broken into massive puzzle-like pieces known as tectonic plates. Imagine the Earth as a giant cracked eggshell, with each piece slowly drifting and bumping into the others. These plates float on top of a softer, semi-molten layer called the asthenosphere, which allows them to move. Though this movement is extremely slow, just a few centimeters every year, it is unstoppable. And over time, the movement of these plates builds up tremendous amounts of stress inside the Earth's crust. Now, when these tectonic plates interact with each other, they don't move smoothly. Sometimes they get stuck. Sometimes they push so hard that rocks bend and store energy like a stretched rubber band. Eventually, that stress becomes too much for the rocks to handle. When the rocks break or slip suddenly, all that stored energy is released in the form of seismic waves. These waves travel through the ground and make the Earth shake. That is what we feel as an earthquake. There are three main ways tectonic plates move that cause most of the world's earthquakes. First, convergent boundaries. This is where two plates collide or push against each other. The immense pressure forces the crust to crumple, creating massive mountain ranges and powerful earthquakes. The Himalayas, for example, were formed this way when the Indian plate collided with the Eurasian plate. Earthquakes in this region are often strong and dangerous because of the constant pressure between the two plates. Second, divergent boundaries. This is where plates move away from each other. When this happens, cracks open in the Earth's crust, and molten rock from beneath rises up to fill the space, creating new land. The Mid-Atlantic Ridge is one of the best examples of this process. While earthquakes at divergent boundaries are usually smaller compared to other types, they still remind us that the Earth is always changing. Third, transform boundaries. This is where plates slide past one another. Because of friction, the plates don't glide smoothly, they get stuck, and stress builds up. When they finally slip, the release of energy can cause violent earthquakes. One of the most famous transform boundaries is the San Andreas Fault in California, which has been responsible for several devastating quakes. Together, these plate movements explain why most earthquakes happen along fault lines, which are cracks in the Earth's crust where stress is released. That's also why regions near plate boundaries, such as the Pacific Ring of Fire, experience frequent and powerful earthquakes. In fact, about 80% of the world's major earthquakes occur around this zone. But tectonic plate movement isn't the only cause of earthquakes. Some are triggered by volcanic activity. When magma pushes its way upward, it puts pressure on the surrounding rocks, causing them to crack and shake. These are called volcanic earthquakes, and they usually occur before or during volcanic eruptions. So, to put it simply, earthquakes are caused when stress builds up in the Earth's crust due to the movement of tectonic plates and then suddenly releases in the form of seismic waves. The plates are always moving, and though we might not feel it daily, they are constantly reshaping our planet. Sometimes, their movements are slow and gentle, forming mountains and valleys over millions of years. but other times, they release energy in a violent burst, shaking the ground and reminding us of nature's raw power. Scientists continue to study earthquakes and tectonic plates to better understand when and where they might happen. While it is still impossible to predict the exact time of an earthquake, research helps us prepare, build safer structures, and reduce the risks. In the end, an earthquake is simply the Earth's way of releasing stress. The ground shakes because the giant plates beneath us are constantly moving, colliding, and sliding. It is a reminder that the ground we stand on, though it feels solid, is always in motion, shaping the world we live in.